dopamine basically acts as a teaching signal. All it does is it helps us, instructs humans to associate events together. Now note, those events in addiction is substance and outcome, substance and feeling, substance and behavior. But we are exposed to a range of internal stimuli and external stimuli. You see, if you think about the pathogenesis, pathophysiology of schizophrenia, aberrant salience, what tends to happen is there's a reward prediction error mismatch constantly from very early on through development. It's a neurodevelopmental sort of some parts of schizophrenia, as we know. So as a result of that, there is a constant mismatch. There is never, or I shouldn't say never, but there is a significant difficulty in this reward prediction error minimization process, which is really what results in psychosis, because there's a stimulus, a red car, leading to a completely significant different outcome or explanation. But we know that this, in some individuals, may happen suddenly, but for others, it's over time. And we know that this process can be sensitized through trauma. Amygdala activation excessively sensitizes the salience network towards aberrant salience. And that's the reason why individuals with trauma can have psychosis, can have bipolar, can have mixed states, etc., including addiction, as we'll see. So therefore, what dopamine's doing is it's simply connecting two aspects. It's there for learning. So dopamine prediction error response belongs to a mechanism that underlies our drive for always wanting more reward. They're like little devils in our brain that drives us to rewards. This becomes even more troubling because of the particular dopamine response characteristics, namely the positive dopamine response activation to positive prediction errors. The dopamine activation occurs when we get more reward than predicted. And we know that this can happen through substances. So that's an exaggerated positive prediction error. But any reward we receive automatically updates the prediction so that a previously larger than predicted reward becomes the norm and no longer triggers a dopamine prediction error surge. This is important. Essentially, what it's telling us is what is unexpected. The way our brains are structured is that the unexpected gradually moves towards becoming the expected, because we cannot operate constantly within uncertainty. So essentially what it's telling us, dopamine prediction error, the salience network is set up to help us deal with uncertainty through the process of minimization or reward prediction errors. This is something that was highlighted by Freud, actually. So there's a saying that the ego, which is really the higher order cognition, likes all problems in a solved state. But you see, the solving occurs differently. For many individuals, this solved state could mean through maladaptive ways, whilst others may actually solve it through actual problem solving. And this is also the reason why we prefer, at times, false reassurance, minimization or reward prediction error, as opposed to an inconvenient truth. Because the ultimate goal for all humans is to minimize these surprise signals. Okay, so if we think about addiction from a neurobiological perspective, it is nothing but an imbalance between the D1 and D2 signaling in the ventral striatum, which is the nucleus accumbens, which is believed to enhance reactivity to drug-predictive cues in addiction. Now, what happens? How does this get reinforced? What we can see here is this is how normal learning occurs. Very relevant to ADHD as well, very relevant to psychoeducation for patients when you're moving them in the recovery phase. You see, normally what happens is when there's an unexpected reward, so think about unexpected reward as something you're learning, right? There is a phasic burst of dopamine. We need that, remember, because of D1. Learning, and then it moves towards habit part of the brain. Early in learning, there's a cued reward. And look what happens here. This is interesting. Dopamine firing moves towards a cue rather than the actual reward. So in the early stages, there's still a dopamine burst, but you can see it's gradually moving towards the left.